Okay, we're back, and in this last of the videos, what we're going to actually be examining is the production of a kernel density surface. Now, I'm doing it in this tool simply because it's an option. There is also a kernel density estimation tool. I will show you that. But what we're going to do here is a similar idea because I want to just get you used to the idea of how hotspot analysis works. Again, our input is our combined wells. I already have it set as a point output. And in this option, what is actually happening in the point to create points to weighted points is that the tool can, in a sense, aggregate or snap points together to give increasing weight. In this case, simply more of them. But what we're really interested in here is the density surface that is being produced. So here I've identified hotspot, and I'm going to call it hotspot kernel. I've already filled that in. But what's important here is we're going to click on the environments option. And what I would like you to do is in our raster analysis, we are going to identify as a mask. And a mask means the area where values will be calculated. And we're going to set the mask as our overall study area dissolved. And then what I would also encourage you typically to do is what we call the processing extent. And I'm also going to set the processing extent to that of the overall area study dissolve. Again, so what we're saying here is these are the areas where we are going to do the work. And this will speed up most of the tools. Once you've done those, click on OK. And now again, I'm going to click OK here to run the tool. And then we'll come back when we see what we get out of it. Okay, we're back, and the results that you see from this, I want to just point out a couple of things. So first of all, what we're seeing are our point hotspot data, okay? And again, the idea behind this data set is that our resulting points, and you see them colored in here, that in fact in this case the aggregate points are assigned levels of value, and again, cold spots to hot spots, if you will. And not surprising, what I want you to kind of think about is that if we had looked back at our original data set, and I'm going to change its symbology here so that we can kind of see our level, what we end up with in terms of these values is that, and again I'm going to go back to a slightly different color scheme so that you can see kind of where we are. If we were to look at these original values when we did it in our quadrant, and I'm going to kind of flip them around here because our colors are inverted. What we need to do, let me just flip this so you can see it the way it used to be. If we look at our quadrants, what we see is our areas of clustering very clearly and our areas of neutral values, etc. And when we look at just the points, however, while much of the data is similar, what you'll notice up here is that our negative or our cold spots don't come out quite the same way. They're somewhat there, but what we really want to focus on here, again, negative clustering is a little bit more difficult to interpret, but here very positive clustering is easy to do. But again, I'm not particularly interested in the point output, and in many respects I don't think it's a meaningful interpretation, but what I am very interested in is our density surface. And so this is one of the outputs. And what you'll notice here is that what I have done is simply put the density in units. And so what we have here is our well count from 0 to 18. And again, this is in standard units. And if you'll notice, that well count exceeds what we see here in our enumeration unit. And that kind of makes sense if you think about it. Our well counts are put into an interpolated surface. So this is a density kernel estimation. And so we're going to get values that exceed the actual counts that we would see in our enumeration units. But now we can see, in fact, where most of the wells fall and where they are less concentrated. And so again, I'm going to turn back on our wells so that we can kind of see how this relates. And again, not surprisingly, our highest density values are in fact where you can see them to be. Here we have all of these now kind of finer resolution areas. And we can also see the very, very low density surfaces. Now, next week, we'll be talking about LiDAR data, and we'll be really getting into the question of what a density estimation means. But in this case, it is sufficient to understand it as a kernel density surface, which is a measure of the concentration or intensity of points. So with that, we're done with our initial Project 1 analysis. We now have enumeration unit densities, we have our fishnet or quadrat densities, and lastly, we have a kernel density estimation surface. Next time.